Hi, ladies and gents. Now here is another equation that we're going to translate from linear into rotational. Linear equation for a constant or average velocity is change in displacement divided by time, and the units are meters per second. Well, in order to translate that into rotational velocity, the symbol that we use for angular displacement is theta, and good old time is still time, but rotational or angular velocity is Greek letter omega. This is lowercase omega. It looks like kind of a soft W. You may be familiar with uppercase omega. It looks like this, and that is the symbol for resistance in electricity, but we don't care about that. I just thought I'd mention it. Rotational velocity, change in displacement in radians per second, and so the units are going to be radians per second. As we go through problems, there is kind of a convention of direction. Positive angular velocities are considered counterclockwise, and that is in the same direction that a math radians are going to go, in that counterclockwise direction. Clockwise motion is by convention consisted of negative angular velocities, but to be honest, as long as you, the problem doer, keep your beans together and be consistent, you can mix them up as long as you know what you're doing. Let's go through an example problem. A car makes 2.5 laps around a circular track in 3 minutes. What is the car's average angular speed? So what do I have? 3.0 minutes, so that's my time, 3.0 minutes. And in order to use our equation, we're going to have to get rid of minutes and go to seconds. There's 60 seconds in a minute, so that's going to equal 180 seconds. The race car makes 2.5 laps, so I've got 2.5. But what do I label this so that I can work with it? Well, a lap is a revolution. So that is going to be my angular displacement, 2.5 revolutions. But in order for me to use this angular velocity equation, I have to have everything in radians. Angular displacement must be in radians. So I'm going to have to convert again. 1 revolution is 2 pi radians. If I do the math, 2.5 times 2 times pi gives me 15.7 radians. And if I take these two values and plug them into my equation, I end up with angular displacement, 15.7 radians, in 180 seconds, and that will give me 0.0872 radians per second, and that is my angular velocity.